So hello guys, welcome back to yet another video where today we'll be solving the fifth problem from the CSES problem set. So let's get started. The question states that we have been given a value n, and what we have to do is we have to create an array such that the difference between the adjacent elements should not be equal to 1. For example, let's say my n value is equal to 5. Then I can create an array, for example 2, 4, 1, 3 and 5. We can clearly see that in this array that is created, the difference between adjacent element is 2. For example, 2 minus 4 is 2, 4 minus 1 is 3, 1 minus 3 is 2 and 3 minus 5 is 2. But let's say we have a value like n is equal to 3. Then what are the different possible combinations that we can have? First one is 1 2 3, then it is 1 3 2, we can have 2 1 3, we can have 2 3 1, we can have 3 1 2, we can have 3 2 1. We can see that in this all the permutations that is available to us, the difference between the adjacent element is always 1. Similar is the case with n is equal to 2. It is 1 2 and it is 2 1. Over here we can again see that the difference between the adjacent element is 1. But let's say for n is equal to 4, we can have something like 2, 4, 1 and 3. Over here the difference between adjacent element is 2, 3 and 2, which is clearly not equal to 1. But for n is equal to 1, we have only one element, and we can say that for n is equal to 1, we can have one element and this does not have any adjacent element, so this is a valid solution. But for n is equal to 3 and for n is equal to 2, we don't have a solution. Hence, we will print our answer as no solution. But for the rest of the values, that is from n is equal to 4 and from n is equal to 4 till 10 to the power 6, we do have a solution. So in that case, how we are going to print it is, what we'll do is we'll start a for loop for I is equal to 2, and we will go all the way up till n, and we will increment the value of I by 2 times, and we will print the value of I. Once this is done, then we will again start a for loop for I is equal to 1, and we will go all the way up till n, and we will again increment it by 2 times, and we will print the value of I. So just to illustrate this process, let's say for n is equal to 5, we start a for loop for I is equal to 2. First we print 2, then we increment it by 2 times, then we print 4. Then we again increment it by 2 times, it becomes 6. But since 6 is not less than equal to 5, this for loop gets breaked and we move on to the next for loop. Now I is equal to 1, we print the value I is 1, increment the value of I by 2 times, it becomes 3. 3 is less than equal to 5, hence we print 3, and we again increment the value of I by 2 times, it becomes 5. Since 5 is equal to 5, we print the value of 5, and I again gets incremented to 7. Now since 7 is not less than or equal to 5, this for loop gets break, and this is our final solution. Over here, the time complexity of the code is O of n plus O of n, which is 2 times of O of n. Similarly, the space complexity is O of 1. So the space complexity is O of 1. We are not using any space over here. So this is the final solution to this problem. So let's just move on to the coding part. Over here we have for n is equal to 1, as I said, there is only one valid solution. We print it and we break from this function. For an n less than equal to 3, there is no solution, hence the answer is no solution. For the rest of the values, we start from 2, increment it by 2 times, and then we print it. Similarly, for I is equal to 1, we increment it by 2 times and we print it. So If you like this video, make sure to hit that like and subscribe button. I'll be coming up with more videos. Until then, take care and bye bye.